So far in this unit about evolution, we have explored the history of the development of evolutionary thought, the evidence that corroborates the theory of evolution, the general idea of how evolution works, and the history of how that idea was developed. We also talked about microevolution, which is the changes within a population or a flux towards a certain gene or allele in a population. And we also talked about macroevolution, which is a product of separation and several different types of speciation events which lead to the formation of different species from previous existing species. So we've painted a picture of evolution as a process by which one species descends from another, and that explains therefore how all life on Earth came to be, and the idea that all life comes from previous existing life with modifications of that previous existing ancestor. But that if you keep reversing this back in time, you would see the idea that all life shares common ancestors, and that the original life forms, from those original life forms, all life on Earth split by successive speciation events. It is going backwards like this that is the most challenging thing for people to accept, because we have observed microevolution repeatedly. We also have observed several instances of new species going forwards into time. But it's really hard for people to believe that going backwards into time, the same process explains all life on Earth. And we discussed in the macroevolution lecture series about how why wouldn't it? And that the fossil record and many other evidence it seems to indicate that the theory as presented is indeed the best explanation for all the data that has been collected. And that's what it makes it a theory. Remember, in the theory of evolution, when you say the word theory, you don't mean just a guess in the way that it's used in society in many ways. Oh, I have a theory about this. In science, when we say the word theory, we mean an explanation based on a lot of evidence collected by, in this case, by many different scientists over a century and a half of data to corroborate this explanation for life. An explanation that not just tells us how life changes over time, but also explains all the functions about life, explains all the things that life does and all the things that life has. So, the theory of evolution is the most comprehensive theory in biology and perhaps the most corroborated theory in biology. Thousands of scientists and thousands of articles and thousands of pieces of research data support the theory of evolution. And actually, there's not any substantial evidence to disprove the theory of evolution. But also remember that in science, you never really seek to prove anything. In fact, you seek to disprove things and to challenge things. And so it is true that we're never going to 100% prove the theory of evolution, just like we won't prove any other theory, like the theory of gravity. The theory of gravity explains how objects are attracted to each other. But we're never going to 100% say this is how it works, because in science we leave an open mind to the idea that new data in the future might lead to a better explanation about the ways that things work. So science does not set out to prove things right. You're just not wrong in science. But that means that when we say the theory of evolution is our explanation for the way that life works, we mean the theory of evolution is the best set of explanations for what currently is understood in science based on all the data that we have collected. And the theory of evolution can also be seen as a fact because of all the facts that we have observed, all the data that has been collected to actually see that evolution has indeed happened across the history of the Earth. So evolution is not just a theory and it's not a fact. It is both a theory and a fact. It's a theory in the sense that explains how things actually change, and it's a fact in the sense that it has been corroborated by a lot of evidence. Now, I'd also like to point out that this idea about the theory of evolution is controversial, and I understand that. And a lot of people are willing to accept the general mechanism for evolution that explains how organisms change, and they understand that life does indeed change over time, and even if it was created, it needs to be some sort of process to make life adapt over many generations to changes in the environment, because clearly the environment has not always been the same. So a lot of people are willing to accept the fact that perhaps there is a mechanism that perhaps is part of the same creation for explaining the way that life changes. Then you start talking about microevolution and the idea that life changes, that species can shift towards a certain look or another. In other words, fluctuations within the gene pool of a species are possible. Just like, you see different kinds of races in the human race, that in itself is microevolution, and that throughout history, because of events, we shift from one or the other. We talked about the population of the United States shifting over the history as an example of that microevolution. people are willing to accept that as well. It starts to become a challenge when we start talking about macroevolution, or the idea that species can come from other species, or that in the future the human race will probably split into different species or go extinct in a process that we call adaptive radiation. Now, this also explains, going backwards into time, that we came from other species, or we have common ancestry, and that we descended from them in modification. And that is perhaps the biggest challenge for most people to accept macroevolution. But we also talk about in the macroevolution lecture series about the abundant amount of evidence that exists, and that we've actually seen repeated examples of both flies, flowering plants, and several other kinds of species, including fish species, where we actually seen evolution actually taking place at the macroevolution level. But it's true that we were never going to be able to see a massive kingdom shift in evolution, because that would take millions of years for us to observe, and we just started collecting information about macroevolution on the last 100 years or so. And so only species that have very short generations, which allow us to see several generations go by, such as flies, for example, we've been able to see. We're not going to be able to see human evolution taking place at the macroevolution level, because that would take a very long time, since human generations take a very, very long time to happen. But that does not mean that the theory is wrong, because all the evidence that can be collected has been corroborated with the way the theory has talked about. Now, I wanted to review this before I start talking about this lecture series on the origin of life, because if it was challenging for people to accept the theory of evolution for what it is, and if there was resistance against that theory because of beliefs, and if there was people that did not really understand or care to understand the theory of evolution and are blinded to these facts about evolution because they think that it's going to contradict their faith, then imagine this topic that we're going to talk about right now, which is the origin of life. The origin of life talks about not how life changes, or how species come from other species, or how species change over time, but it talks about how does life begin in the first place. Now, it's very important that you understand that the origin of life is not the same thing as the change in life. That the origin of species, as explained by the process of evolution, from microevolution to macroevolution, it is not the same thing as the origin of life or the way that life started. In fact, it doesn't even make sense to talk about evolution of life in the sense of how life started, because evolution is a characteristic of life. There is no evolution until there is life. So you can't mix one thing up with the other. And although traditionally teachers talk about the origin of life together with the evolutionary theory unit, it is important to understand that they are two separate things, that the origin of life is not the same thing as the theory of evolution. So it is possible for you to accept the theory of evolution even if you don't accept the origin of life. And it is true that while the theory of evolution is corroborated by a lot of evidence over a century and a half of scientists studying this, and we've observed every single aspect of evolution. We've seen microevolution, macroevolution, the appearance of new mutations that increase the information of the genetic code, changes in genetic code that lead to better adaptations to the species, new structures evolving. We've seen shifts in the populations. We've seen completely different species come from other species, and we've seen the fossil records show a history of progression of changes in adaptive radiation throughout the history of the Earth. We've seen all of that, and so there's a lot of evidence for the theory of evolution as a whole, and it's the best theory that explains the way that life is and the way that life works. Now, when you talk about the origin of life, then it's a little bit different. Yes, there is a lot of logic and scientific principles and physical principles, chemical principles that explain the way that scientist says life started. But it's more like a hypothesis than an actual theory, because remember what I just talked about, the idea that a theory is based on a lot of evidence that's collected on an observable event, or in other words, something that explains the facts. Unfortunately, we could not say the same thing about the origin of life hypothesis that science presents. The science presents a very good explanation for the way that life could have started. But since we have never actually observed the beginning of life, since we have never observed abiogenesis actually occurring, then we can actually say that abiogenesis would be, say, a theory in science. Now, there is a lot of evidence to support each of the possible steps that we're going to present in this lecture series. But that goes a long way from saying that that's how these steps actually happened, In other words, the theory of evolution has way more support than the idea of abiogenesis that we're going to talk about in this lecture series. Having said that, this is still the best scientific explanation for the origin of life. But remember, that is a different thing from the change in life or the origin of species. And that the controversy that exists about evolution is ridiculous, because no scientist argues against evolution. You could have perhaps some arguments against the origin of life, but not against evolution. The evolutionary theory as it is being supported over and over again, and no true scientist that truly understands and cares to be open-minded and take a hard look at the data is going to challenge the theory of evolution. Now, about the origin of life is a completely different story, and I hope that in this lecture series I do it justice, so that you understand how scientists presents this opinion or this idea, yes, based on scientific principles and based on evidence, but that it's a little far still from a far cry from actual forming something that I would call a theory that actually explains the origin of life. Let's talk about that in this lecture series, and I'll see you then.